Now let's start with Gauss-Seidel method. Here is one question. Just copy this. Here goes it. For the system shown in figure, determine the voltages at the end of first iteration by Gauss-Seidel method. Take alpha is equal to 1 and the bus specification are given in table. All the bus specifications and the singular diagram of the power system is given. But it is also given that all the elements are admittance in per unit. That means this 1 minus 5j, 0.5 minus 4j, etc. are the values in admittance. Okay. And before proceeding any question in load flow analysis, we have to read the question twice. Let's read it again. For the system shown in figure, determine the voltages. That means you are asked to calculate the voltages of each bus. At the end of first iteration, you need to perform only one iteration, and by using Gauss-Seidel method or rather RGS method, you are asked to take alpha as equal to 1. What is alpha? Alpha is our accelerating factor. It is to be taken as 1. Okay, so here is our question. Bus specification is also given. So before proceeding to its solution, we should clearly understand which all are these buses. Yes, let's work out it. Bus number 1. Active power is not specified, reactive power is not specified, whereas magnitude of the voltage and the angle of voltage is specified. So what type of bus it could be? Yes, it could be slack bus. Now move on to the second bus. Active power is given as 0.2. Whereas reactive power is not given. Instead something different is given. What is that? Here, reactive power is not given. Instead a limit is given here, right? 0.1 less than or equal to Q2 less than or equal to 1. What does this indicate? This indicates that Q2 is not given. Instead a limit is given. Then now here magnitude of the voltage is given. So we can say active power P is given and voltage V is given. So what type of bus it could be? Yes, it could be generator bus or a PV bus, isn't it? Now next, third bus. Active power P is specified, reactive power Q is specified. Fourth bus. Active power P is specified, reactive power Q is specified. So what about these two bus? These two bus comes under what? It is load bus or otherwise called as PQ bus. Okay, so first one is a slack bus, second one is a PV bus or generator bus, third and fourth one is load bus or rather are PQ bus. So this is the abstract of our question. So once you get a question in load flow analysis, first you need to take the essence out from that question by considering which all are the known parameters, which all are the unknown parameters. Now from this data is given, can you tell me which all are the unknown parameters? Unknown means those things which we need to calculate. Here we are asked to calculate voltages. We have already mentioned that voltage has two parts. What are the two parts of voltage? One is the magnitude part and another one is the angle part. How will you represent angle? Angle is represented as delta. So every voltages have what? Magnitude part and its angle part. So in the slack bus, do we need to calculate its magnitude and its angle? No, because it is given. Now the second bus, what all things we need to calculate? We need to calculate magnitude. Do we need to calculate magnitude? No, magnitude is given. So here you need to calculate delta only. And in the third and fourth bus, neither magnitude nor angle is given. We need to calculate both magnitude and angle of third bus, both magnitude and angle of voltage of the fourth bus. So which all are the parameters to be calculated? Yes, the first thing is we need to calculate delta 2. Then we need to calculate what? V3, magnitude and angle, delta 3. Then V4, magnitude and its angle delta 4. So these are the parameters we need to calculate. Hope the analysis of the question is clear to you. Now let's proceed with its solution. Now we are moving on to its solution. What was our first step? Our first step was calculation of admittance matrix or Y bus admittance matrix. So I hope all of you know how to calculate this bus admittance matrix. Still, this is our first element or the diagonal element, second diagonal element, third diagonal element and fourth diagonal element. How will you calculate the diagonal elements in bus admittance matrix? Yes, it is actually the sum of admittance connected to particular bus, isn't it? So for example, Y11 means the 1 minus 5j is connected, 1.2 minus 4j is connected. So sum of these two, isn't it? That is 1 minus 5j and 1 minus 2 minus 4j. These are the two admittance connected to the first bus. That is our first element. Now how do you calculate this off diagonal element? This is Y12. That is the negative of the admittance connected between 1 and 2. Here the admittance is 1 minus 5j. Negative of that admittance means minus 1 plus 5j. So like that it proceeds and this element is 0. Why? Because this element corresponds to the admittance between bus number 1 and bus number 4. This is a bus number 1 and this is bus number 4. Now is there any connection between bus number 1 and 4? No. So hence we can say that that particular element is 0. All these things you might be knowing, still just refresh what we have studied. So that is our first step, bus admittance matrix. Now our second step also, you know it already, that is initialization of bus voltage. We know that the first bus is slack bus and the voltage given was 1.06 and angle was 0. Now second bus was PV bus. Before this, how do we initialize bus voltage? We will be initializing bus voltage by assuming the magnitude as 1 if it is not given. But in this case, for the second bus, which is a PV bus, voltage magnitude is given as 1.04. So we cannot assume the magnitude of voltage as 1. Instead, we need to assume the magnitude of the voltage as 1.04 itself. Whereas for the third bus and the fourth bus, the magnitude of the voltage is not given. So you could assume it as 1. And in all the three cases, the angle is not given. So you can undoubtedly assume that magnitude of the angle of the voltage is 0. So this was our second step, initialization of bus voltage. Now, coming back to our question. What was given in the question? In this question, it was given a limit, isn't it? A limit was given. What is this limit? Q2. Q2 means what? Reactive power of bus 2. It should lie between 0.1 and 1 per unit. So we don't know the value of Q2. Only by knowing the value of Q2 we can say whether it lies between those two, isn't it? So we need to know what is the value of that Q2. And this was the equation for calculating reactive power of a particular bus that we have dealt already. So this is the equation for calculating reactive power of a particular bus. And what does this P indicate? P indicate the bus number. What does this K indicate? This K indicate iteration count. All these things we know, right? Now we are going to calculate the reactive power of second bus. So we have put P is equal to 2. And for the first iteration, so put K is equal to 0. So you will be getting Q2 1. We are going to calculate it as equal to minus 1 into imaginary part of something. Okay, imaginary part of something. And in this equation, we just substituted the values. That's it. Vp raised to k. That means V2 raised to 0. All these things we have just substituted. Okay. So upon substituting the values, you got like this. Minus 1 into imaginary part of this equation. What is the this 0.0458, is this the imaginary part of the equation? Is it imaginary part? No, it is a real part. So it is not the imaginary part. Then what is the imaginary part? Yes, 0.1456 is the imaginary part. Not simply 0.1456 minus 0.1456. So your Q2 is equal to this minus 1 into imaginary part. So minus 0.1456 is the imaginary part. So your Q2 is equal to 0.1456. So this was the answer you got while calculating Q2. But in the question, a limit is given. That is, the Q2 should be between 0.1 and 1. Now let's check. Yes, 0.1 less than or equal to Q2. What is the value of Q2 now? What is the value of Q2? Q2 is now 0.1456. Less than or equal to 1. Yes, 0.1456 lies between this limit. So you can say that the limit or the range is satisfied. Hence, you can treat this bus as PV bus, or you can treat this bus as generator bus. Okay. So that means if the range is satisfied, you can treat the bus as generator bus itself. If the range is not satisfied, you cannot treat this bus as generator bus. We will discuss a problem on that later. Now in this particular question, you got the reactive power like this, and when you checked it with a limit, you could say that the reactive power is satisfied, and you can treat the bus as generator bus itself. Now next step is calculation of bus voltages. That you know how to calculate bus voltages, because we know this equation, right? Vp is equal to 1 by ypp into pp minus jqp. This equation is already known. We have discussed this equation many times. Okay, so since you are calculating for bus number 2, you will be substituting the value of p with 2. And since this is for first iteration, your value of k will be equal to 0. So upon substituting the values, that is v2 raised to 1 is equal to 1 by y22 into, this is the equation. Okay, so at any point of time, if you find any confusion that, or rather this video is too fast, you just pause it down and just copy or just calculate it and verify your answer with this. Okay. Now in this, we have just expanded this equation. Now here P2, value of P2 and Q2, we have given positive values 0.5 and 0.1456. This is a calculated value right now. These are given positive values because the bus here, it is generator bus, because for a generator bus, if specific notations or negative sign or positive signs are not given in the question, you can treat the generator bus as positive itself. That is 0.5 plus 0.5 and plus 1.1456. Okay, so on substituting these values, all the other values are known to you. We have discussed this detailed calculation in the previous lectures. Okay, so we have just substituted all our known values and have calculated. Only on this area you should be much more conscious, or you need to concentrate on this area where you'll be given positive sign, because this bus is generator bus. And you got an answer like this. Now tell me, is the voltage of the second bus is equal to 1.0496 angle 2.05? No. Why? Because the magnitude is, here it is 1.0496. Do we need to calculate the magnitude of second bus voltage? No, because the magnitude is specified as 1.04 itself. So you can neglect this magnitude and you can take the angle from the calculation, that is 2.05. Take angle from the calculated voltage, that is 2.05. So you can say your magnitude of the second bus, your voltage of the second bus is equal to 1.04, which is a specified value, and 2.05, that is the angle, which is the calculated value. Hope this is clear to you. Now the next step is very much familiar to you. For bus number 3 and bus number 4 are load bus. So for calculating voltage of third bus, you will put P is equal to 3, and since it is the first iteration, K is equal to 0. Again, the same equation you will be using, and you will be substituting the same. And here the thing you should be thorough with it. Here it is, the active power is given a negative sign, and your reactive power was actually zero point 0.3. You took it as minus zero point 0.3. Why? Because the third bus is load bus. For the load bus, the reactive power will be reactive power and active power will be taken as negative. So this is one thing you need to be very very careful in it. And likewise, you got the value as third bus voltage is like this. You got it like this. And similarly, you need to calculate for bus number 4. What is it for bus number 4? You will be putting P is equal to 4, and since it is for the first iteration, put K is equal to 0. Okay, and on substituting these values, what about the polarity for the P4 and polarity for Q4? These are powers. What type of bus is fourth bus? The fourth bus is load bus. So your P and Q should be given negative sign. So you can see that here it is given minus 0.2. Okay, here also it was minus 0.2, 0.1. See here, but it is P minus Q. So here you got the sign as positive. Okay, and you got this bus voltage like this. So finally, after completing this, you just don't leave your answer like this. And whatever it may be, whatever may be the answer you got, you just write the voltages of the different buses that you got after the first iteration. Because while evaluating this Gauss Seidel method, it is not mandatory that you'll be getting all the digits correct. Minor errors can occur. Okay, you just ignore that. Try to complete it. Try to be more careful while doing this problem. Still, you don't worry about it. You just proceed with the steps in this similar fashion, and finally consolidate the value of voltages like this. And if you in the question you are asked to perform a second iteration, which is not generally asked in our university question, but even though if it is asked, what you have to do is you have to repeat the same steps again, but with k is equal to 1. So far we have been doing this problem by substituting k is equal to 0. But if you want to perform the second iteration, you are supposed to put the value for k as 1 and repeat the same steps. Okay, so this is the question, and I hope this is much clear to you. So once again, just this was the case. Our first step was the calculation of admittance matrix, and our second step was initialization of bus voltages. Since for the second bus the magnitude of the voltage is given as 1.04, we assumed the initial value for the second bus as 1.04 plus J0. And since a generator bus is included here, you are supposed to calculate the generator the reactive power of that particular bus. And once you calculate the reactive power, you have to check with that particular limit, and if that particular limit is satisfied, you can say that you can treat that particular bus as generator bus. Else, but there is some other step that we will discuss. Then likewise we will be calculating the bus voltages by using our equation Vp is equal to 1 by Ypp, this equation, and by substituting sufficient values for P and sufficient values for K, you will be calculating the voltages of each bus after first iteration. So this was the case that we did. I hope this much is clear. This particular question is clear to you. Now moving on to our next question. So here goes it. For the same question, that is for the same question that we did just before, let the power constraint of bus number 2 be changed to 0.2 less than or equal to Q2 less than or equal to 1. While all other data remains same, solve the voltages at the end of first iteration by Gauss Seidel method. So here only one difference given is the limit. the limit here is changed as 0.2 less than or equal to q2 less than or equal to 1. While all other data remain same, we need to find the voltages at the end of first iteration by using Gauss-Seidel method. Okay, all other data remain same. That means our first step is undoubtedly same. That is Y bus, the same Y bus in the previous case. Now step 2, initialization of bus voltages. What is our initialization? The same initialization, no difference because the buses are same. Slack bus, 1 generator bus and 2 PQ bus. This is how we initialize. Okay, so that step is again same. Third step is again same. What was the third step? We need to calculate the reactive power. Since the step was same, I didn't repeat it again. So here, whatever it may be, we have calculated and our value was 0.1456. Now what was our next step? Our next step was to compare it with the limit, check with the limit. Now, yes, this value is less than 1, but this value is not greater than 0.2. So that means our limit is violated. Now, which limit is violated? Is this limit violated? No, this limit is satisfied because your reactive power is less than 1. This is okay. Now, what about this limit? Your reactive power is not greater than 0.2. So, which limit is violated? This limit. This limit means lower limit is violated. So, what will we do if your limit is violated? In the previous case, the limit was not violated. So what did we do? We proceed the problem by treating the bus as generator bus itself. But here the limit is violated, which means what? Your bus cannot, your bus can no longer be treated as generator bus. If it is to be treated as generator bus, it should satisfy the limit. Here the limit is not satisfied, so you cannot treat your bus as generator bus. Instead, you treat your bus as load bus. You cannot now treat it as generator bus. You have to treat it as load bus. Okay. And what should be, if it is load bus, then it should have a value for reactive power, right? Isn't it? For a load bus, it should have active power, it should have reactive power. And in this particular, we are going to treat it as load bus. Now, what is the reactive power of that particular load bus? That is, the reactive power value will be equal to the violated limit. Here, which is the violated limit? 0.2 is the violated limit. So, you will be setting our reactive power as 0.2. Clear? So, I am again repeating it. This reactive power you got like this after calculation, and you checked with the limit. You found that your limit is not satisfied or your limit is violated. Once your limit is violated, you cannot treat this value as 0.1456. Instead, you have to set the reactive power value as the limit violated. Here this limit is violated. That is 0.2 is violated. So you have to set it as 0.2. Okay, and one more thing is that once the limit is violated, you cannot treat that particular bus as generator bus. Instead, you are supposed to treat that bus as load bus, but positive value is given for its active power and reactive power. I am specifying this. Why? Because till now we have been studying that this for if a load bus is considered, its active power and reactive power should be taken as negative. But in this particular case, it was not actually load bus, it was actually generator bus. But since the limit is violated, we are going to treat it as a load bus for calculation. But originally it was generator bus. So your value of active power and reactive power will be positive itself, not negative. Clear? Now, once the bus has become load bus, we again need to initialize the voltage. Why? Because in the previous case we have initialized the bus voltage as 1.04 plus J0. Why? Because we treated it as generator bus. In this particular case we cannot treat it as a generator bus. So if it is not a generator bus, its magnitude of voltage is not specified. So you will be setting it as 1. Okay. Now the next step is onwards the same. That is P is equal to 2 and K is equal to 0 for first iteration. Proceeding in the similar way. See here, the P and Q are given as positive sign. Okay, same value is given and you got the value. Okay, now for the third bus, for calculating the voltage of the third bus, you put P is equal to 3 and K is equal to 0. That is for the first iteration. In the similar fashion, you proceed. Here you will be putting a negative sign for active power and reactive power. Why? Because this was originally load bus itself. So you could give the values as negative for the active and reactive power. So you got the value of the bus voltage, third bus voltage, and similarly you will be proceeding in the similar way for the fourth bus voltage. You will be substituting P is equal to 4 and K is equal to 0 for the first iteration. Now proceeding in the similar way, you will be getting a particular voltage. So this is how. And after completing this, you just consolidate the voltages that you got after each iteration. I mean, after for each bus after the first iteration. Now again, if you are asked to perform the second iteration, put K is equal to 1 and proceed in the similar way. Hope this case is clear. So this is a special case and this is an exceptional case. What was this exceptional case? That is, the limit is violated. Which limit is violated? Lower limit. You'll be setting reactive power value is equal to the violated limit and you'll be treating the bus as load bus, but the value of active and reactive power will be given as positive. Okay, I hope this is clear to you. Now moving on and to another special case. Again, for the same question, the constraint is changed like this. Now let's start from here only, because till those steps now it is familiar to you. What was the first step? First step was the calculation of admittance matrix. Second step was the initialization of the bus voltage. Third step was the calculation of reactive power, which we got as 0.1456. Now you check this with a limit. Yes, 0.05 is not violated, whereas 0.12 is violated. Your value is greater than 0.12. So here which limit is violated? Whether the lower limit violated or whether the upper limit violated? Yes, your upper limit is violated. This is the violated limit. So the limit violated is the upper limit. So what should you do? You have to substitute the reactive power is equal to the violated limit. What is a violated limit? 0.12 is a violated limit. So you have to substitute Q2 is equal to 0.12. Note over. What is the next thing you need to do? We need to treat the bus as load bus, because it cannot be treated as generator bus because the limit is violated. Once the limit is violated, you need to treat the bus as load bus, but what we need to do? P and Q will be given positive values, not negative values. Okay, again proceeding further, calculate the value of voltage by substituting P is equal to 2 for calculating the second bus voltage in the similar fashion. Similarly, V3 and V4 by substituting P is equal to 3 and 4 respectively, you can calculate. Okay, hope this much is clear to you. Now, after this, these are some takeaway points by considering this. That is, first we need to check whether the given bus is PV bus, that is a generator bus, or PQ bus, that is the load bus. Okay, now if it is PV bus, you need to calculate what? Reactive power, and check whether the reactive power is there in the between the specified limits. If the limit is satisfied, what do you need to do? You can treat the bus as generator bus itself and proceed in the similar way. And since the generator bus, what you will be taking, P and Q will be taken as positive. Now, if the limit is violated, you need to set Q is the limit violated and you have to treat the bus as load bus. Now, in such cases, even though it is load bus, take P and Q as positive itself. This was the case that we were addressing right now. So these are some points that need to be considered while doing the problem in Gauss-Seidel method. Hope this much is clear to you. Then we will be proceeding to the next special. I cannot say it as a special case, another set of problem. So to make you much more familiarized with this method. Yet another question in Gauss-Seidel method. In the system shown in figure, generators are connected to all bus. So this color seems to be not good. While loads are in bus number 2 and 3. Specification of buses are also given. Line impedances are given in the table. Assume all bus other than slack bus are PQ. Oh, it is directly given. The buses are PQ. By taking flat voltage profile, we will see what it is. Flat voltage profile. Determine the bus voltages at the end of first iteration by Gauss-Seidel method. Okay, we will see to it. Yes, the datas are given. Here the impedances are given. Now, what is the first step? Yes, now tell me. You have been solving so many problems, and now tell me what is the first step? Yes, calculation of Y bus. Now, is there any issue with the calculation of Y bus? Obviously not. Yes, there is an issue. Not cannot be treated as an issue. Still, since the given values are all in impedance. Okay, so what we need to do, you should first convert this impedance to admittance. This is the first, this most of you will be failed to what do you call it's actually careless mistake. You will be knowing all the steps of Gauss-Seidel method, and you directly start with this method step, and you'll be doing all this iterations, everything you'll do, but your first step most of you might be forgetting to convert this impedance to admittance. So please keep in mind, please be careful whether the given and check whether the given values are in admittance or in impedance. Here it is clearly said that the impedances are given. In some questions it may not be given here, like impedances are given. It will not be what do you call given in the question. Instead, it will be given like this. By seeing this, you should understand that these are in impedance. Okay, coming back. So given is the impedance, so correspondingly you need to calculate its admittance first, then you proceed with calculating Y bus. Okay, so you know how to calculate this Y bus, and I am not going to explain it once again here. Now what is the second step? Yes, second step is initialization of the bus voltage. This step is quite simple because it is given in the question that all the buses except first bus is slack bus. So if all the buses except the slack bus is the load bus, you can directly assume the magnitude as 1 and the angle as 0. Only issue will be there. There will be one issue only when there is generated bus. Here, once you see the question and you see that all the buses are load bus, no issue with the question. You can without any concern you can directly proceed with the question. Okay, so here the slack bus value is given as 1.05, and the voltages of the second, third and fourth bus, which is the load bus, is assumed as 1 plus J0. Yes, proceeding just like that. Step, what is the step? Calculation of bus voltages. First it is given like this and all. Okay, everything is given. Now you could raise one question over here, because here the active power and reactive power is given positive sign. Why? It is a load bus. As far as our knowledge gained so far, it should have been given the negative sign. Then why here it is positive sign? Yes, that was one important thing in this question. Coming back to this question, see, just observe this question. Here the sign, that is polarity of this powers, are given here directly, which indicates in the question itself the polarity is given, whereas in the previous question every values were given as positive. It is up to us to give the positive or negative sign. So what did we do? We have considered the load buses as negatives, given negative sign, and the generator buses were given positive sign. But in this question, it is not our choice. Whereas in the question itself, it is given which all values are positive and which all values are negative. So in this type of questions, you first observe the question, and if it is given like this, that is in the question itself polarity of the powers are given, then please do not assume it is as negative for load bus or it is positive for generator bus. Instead, take the polarity as such given in the question, irrespective of whether the bus is load bus or generator bus. Okay, so while doing a problem, please do take care of these values as well. Yes, coming back. So that's why here it is given as positive 0.5 and the value was negative 0.2, so you substituted it like this. Okay, so that's it. Here it is the PQ second bus voltage, and this is for the case for third bus voltage in the similar fashion. -1 is a given value and 0.5 is a given value. We are not taking any negative sign here because whatever may be the polarity given in the question, we are directly taking that value over here. Okay, now this is the case how you proceed with the third bus, and similarly for the fourth bus. All other things, there is no issue with the question because all the buses are load bus. Only when generator bus comes, it creates some issue. Okay, so from these questions, you might understand that the first thing is you need to check whether admittance is given or impedance is given. Another thing is that in the question whether P, that is active power P, and reactive power Q are given polarity. If the polarity is given in the question, you directly take that polarity. No need to assume any polarity. If the polarities are not given, that means all the active powers and all the reactive powers are given positive sign in the question, then you should understand that in your while solving load bus should be given negative sign and generator bus should be given positive. Okay, all other concepts and all other calculations remains same in this particular question. No further issue with this particular question. Here comes. Now for the same question, here something is here. Second bus is PV. What is PV? PV means generator bus. Yes, now a real headache came. Because whenever there is generator bus, there is a real headache. So your second bus is now PV bus. In the previous question, the second bus was load bus, but now here it is what? Generator bus, and the magnitude of the voltage is given as 1.07. So we cannot assume the magnitude as 1. It is given here it as 1.07. And power constraint. Constraint just means limit. Okay. So your reactive power constraint is between 0.3 and 1. With all other data remain same, calculate the voltages at the end of first iteration by Gauss-Seidel method. Yes, how do we proceed? Again, the first step, Y bus, same Y bus. We haven't written it again. The same, very same Y bus. And this is our question, and here was our modification. And the magnitude of the voltage is specified as 1.07. Our second step is initialization of bus voltage, and this is how we initialized the bus voltage. Okay, so the slack bus voltage was given as 1.05 and angle was given as 0, and the second case it was generator bus, so magnitude is given as 1.07, angle is not given, so we assumed it as 0. Third bus and fourth bus are load bus, where we assumed the magnitude as 1 and the angle as 0. So if a generator bus is there, our next step will be the calculation of reactive power. How do we calculate the reactive power? In the same fashion, we will be calculating the reactive power, and we got the reactive power calculated as like this, 0.3531. Now let's check it with the limit. What was our limit? Our limit was this. Here your limit is satisfied because your value is between this 0.3 and 1, so your limit is satisfied. So what will we do when the limit is satisfied? Once the limit is satisfied, we will be setting the same value. No need to set any limit. We can treat the bus as PV bus and we can proceed. No issue. Limit is satisfied. No issue. Our headache is over. Okay. So how will we proceed? Our usual pattern. We will be calculating the voltage of the second bus is equal to P2 minus JQ2. What is Q2? We'll be substituting this, isn't it? This is our Q2. And we'll be substituting it, and finally you'll be getting the voltage of the second bus. Once you get this value, do we take this magnitude? No, we will not take this magnitude. Why? We can ignore this magnitude. Why? Because this magnitude is already specified as 1.07. So why do we need to take this as a magnitude? We'll be taking the already specified value as a magnitude, but we'll be taking the angle. So then it will be taking the angle. So this is the voltage of the second bus. Now no issue, because the third and fourth bus are what bus? Load bus. So you'll be proceeding in the similar fashion. Okay, so this is a case. Once the generator bus is there, you need to calculate the reactive power and check the value of the reactive power with the limits. That's it. Now for the same question, your constraint is being changed like this. What will we do? If the say for the same question, if the if the constraint is changed like this, first step is pi bus. Second step is initialization of bus voltages. We initialized like this. Third step is calculation. We calculated like this. We are going to check with the limit. Oh, here our limit is violated. Which limit is violated? Yes, this limit is violated. 0.4 is violated. So what will be our next step? It is violated. So we need to treat the bus as load bus. And you have to set the value of the reactive power as the violated limit. What is the violated limit? 0.4 is our violated limit. We will be setting like that. Once it is treated as load bus, then you need to initialize your bus voltage like this. Isn't it? Magnitude is now 1. Now again proceed in the similar way. So that was the case, and you can proceed for bus number voltage 3 and 4 in the similar way that we did before. Now yes, yet another set of question for the network shown in figure. Obtain the complex busbar voltage. Oh, complex busbar voltage. Busbar voltage simply means the voltage magnitude and angle. That's all. At the end of first iteration, using Gauss seidel method, bus 1 is slack bus with value is given. Take P2 plus JQ2 is something like this. P3 is this and V3 is okay. All those values are given. Now we will see. So this is our system and line. Impedances are given. So first step is calculation of Y bus, but the impedances are given. So what should we do? We need to convert those impedance to admittance first, and later on we can proceed with the question. Yes, this is our bus admittance matrix. Now next is initialization of bus voltage. First bus is slack bus whose value is given. Second bus is a load bus, its value is given as 1 plus J0. Third bus is generator bus and whose magnitude is given in the question as 1.02. Angle is not given. We need to calculate it. So this is how initialized this. Now next step is calculate. If there is a generator bus, you are supposed to calculate this, right? So you are calculating this. So before calculating this, we are calculating the second bus voltage. In the similar way, you got the voltage, and you'll be calculating the reactive power. You got the reactive power like this. Here no limit is given. In the question there is no limit. Then no limit is given, you need not compare it with another limit. You just go ahead with this value. Treat this bus as generator bus itself and you go ahead in the same way. But after getting the answer, you will not take its magnitude. Instead, you will be taking the magnitude which is specified in the question, because the bus is a generator bus. Now we are moving on to yet another special case. So in some cases, P and Q will not be directly given. Instead, it would be given like this: generator power, generator reactive power, load active power, load reactive power, something like that. See, consider this. For the second bus, we can say that active power of generation and active power of the load is given. So what is the active power of that bus? Generated power minus load power. Generator power is given as 0.2, load power is given as 0. So 0.2 minus 0, that is 0.2. This is the active power of the second bus. Now active power of the third bus is generated power minus load power. Generated power is 0 and load power is 0.2. So it would be minus 0.2. Now what about the reactive power? Here generated reactive power is not given and load is also not given. That means it is not specified. Hmm? Whereas in the case of third bus, the reactive power generator is given as 0, whereas load is given as 0.5. So generated minus load, 0 minus 0.5, you'll be getting as 0.5. So in some questions, your details will be given like this. So in such cases, you'll be calculating the active power and reactive power like this. So with this, we are concluding with our Gauss-Seidel method, because in this lecture we have completed all those special cases of Gauss-Seidel method and everything like that. So in this Gauss-Seidel method, in our university question, usually one question will be by using Gauss-Seidel method usually, or its algorithm or flowchart. Usually the problem using Newton-Raphson method will not be asked in our university question, but we don't know in this time how it would be. Still, Gauss-Seidel method is much more convenient to you at this point of time in calculation. You should be very careful while calculating the y bus, starting from the y bus. Step 1 y bus calculation. For each step, in the valuation point of view, each step there will be points. So even if you don't know how to solve it, you at least solve the first step, that is calculation of y bus. Second step is also quite easy, initialization of bus voltage. Now, if all the buses are load bus, there is no issue with the question. You can directly solve it. No issue. It is very simple. But if generator bus is given in the question, please do remember that you need to calculate the reactive power of that particular question. That particular bus. Then you compare it with the limit. If the limit is satisfied, you treat the bus as generator bus itself. If the limit is not satisfied, you will treat the bus as load bus. Okay, so that all are the special cases addressing in a Gauss-Seidel method. So I hope you all are now I cannot say thorough, you all know now aware of the different steps involved in Gauss-Seidel method. Please to study well these steps and come back to the next lecture, because in the next lecture we will be discussing the steps or rather the algorithm and the flowchart for Gauss-Seidel method. So once you know how to proceed with a particular problem in Gauss-Seidel method, it is easy for you to write the different steps and draw a flowchart. Okay, so if you have any doubt in these sections, please feel free to contact me or write a comment or at least message me or mail me. Okay, so here we are concluding with our Gauss-Seidel method of load flow analysis. Thank you.